Okay, first of all, inductance is that thing you multiply by the rate of change of current to get the induced EMF. And Lenz's law tells you things and so forth that I think you understand, I hope. What's induced EMF? It's the rate of change of flux through the region bounded by a closed curve, and that would be the EMF around the curve. To get the inductance of a loop, coil, or whatever, and our problem was simply estimate the inductance of this thing. People wanted to use conductivity and resistance and everything, which is a good instinct, but it doesn't make a bit of difference. All that matters is the response of the magnetic field to the current. So if you know the magnetic field as a function of current, then you know the inductance. Of course, you need to put that idea together. Okay? And you know it because the magnetic field is going to be some multiple of the current. So the rate of change of the magnetic field is going to be the same multiple of the rate of change of the current, which is inductance. Okay? So you need to put that together. Now, another thing, okay, current is dq dt, voltage across capacitors Q over C, where you've got a resistor, capacitor, and some variable source. Okay? Variable source of EMF. Haven't really seen that symbol before. That's kind of the symbol. If you look in your book, you'll see it. Okay, so we assume we have a current. Some maximum current times the cosine of omega t. So maximum current is just the amplitude of the current, right? The question is, what's the voltage across the capacitor as a function of t? So what were your thoughts? Except what maybe Elam said? Trying to remove knowledge differential equations with this thing, but of course.
Originally thought of trying to make a function of Q and then take the derivative with respect to T, but
Okay, so
zero. That doesn't help.
well, you know I, so you know dq dt, right? So you're on the right track. You're just going the wrong direction, I think. If I heard everything you said, I got an appointment to get my hearing aids checked this afternoon. dq dt is I, which is this. Okay? Now, among other things, this means, I should draw my circle first. Okay? This means that you can have a reference circle here, right? With the cosine of omega t represented here. So there's omega t. At this point, there's cosine of omega t. Omega t being the angle between the positive x-axis and here, and I don't have to explain the reference circle, I hope. Okay? We've used it enough times since September, and it's now late April. Okay? So, here we have this, right? So we have this picture as we move around here. The cosine goes back and forth here. So we go from maximum to 0 to negative maximum to 0 to maximum and so forth. We understand this. Okay, so what we want is a picture of how Q behaves. Okay? So if this is a unit circle, this is our cosine. And we just change the radius of the circle so that it represents I max, and we have our current, right? But of course, we ultimately are going to want our voltage, so we take the resistance into account, so we'll get to that. But we want to see if the argument of the cosine is omega t, what's the argument of our capacitor voltage? Okay? Well, that's going to be the argument of Q. The argument just means what you take the cosine of or the sine of, right? For the argument of the cosine is omega t. Okay, so what can you say about Q? If you know the derivative is this, how do you find the Q function?
Is the integral?
Yeah, you
of that
integrate this.
With respect to t?
So it's an antiderivative of I max cosine of omega t with respect to t. You should be able to do that integral instantly in your head. What is it?
I max over omega.
Be
Negative.
quiet.
Negative, actually. Well,
Oh, no, you shouldn't have said that either.
no.
Okay, well,
Nope, I was wrong. It'll be positive.
because you're doing these integrals a lot. I want to pull this out of other people so they'll think, right? And then you can verify when I make a mistake. You know, you're the expert. I'm just a bonehead that's trying to get you to understand this, right? Okay? So, yeah. Okay, so anyhow, it's negative I max over omega sine of omega t. Right?
It's not.
I get, why
It's
is
not
it,
negative.
why is it
Oh, yeah.
over omega instead of times omega?
If you take the derivative of the sine of omega t, what do you get?
That's the derivative of cosine.
What's the derivative of the sine of omega t? All symbols.
It'd be negative omega cosine of omega t, right?
Not negative, but I screwed you up by putting the negative there. It would be omega cosine of omega t, right?
Right.
And if you multiply that by I max over omega, what do you get?
You get I max cosine of
You
omega
get
t.
this. So you just check. And if you've been doing integrals without checking them, you haven't been doing integrals. You never learn to do integration unless you're checking yourself, because then things become obvious. Otherwise, they don't stick with you. And if you do what people are apparently in the habit of doing in this culture, which is doing it and hoping it's right, without checking it, it's a terrible, terrible, terrible habit. We have a whole generation of people who are totally incompetent because they don't check their work. And you have a very short time in which to become competent, because Virginia Tech ain't going to tolerate incompetence, right? And at least one is going to be a junior there next year. A couple others are going to be freshmen. And some people in between, I think. Anyhow, whatever, okay? And some people won't be there for another year. I don't know where you're going, but I think that's where most of you are likely to be headed. Okay, so we have this, right? And if that's not automatic, you need to spend an hour a day this summer making it automatic. You can afford an hour a day. You need something to engage your brain, although you do need downtime, right? An hour a day won't interfere seriously with your downtime, but when you're in downtime, it's tough to do, but you need to do it. You'll be happier. You'll be more successful. You will be far less stressed 6 months from now. Okay? Got it? Okay, end of tirade. Now, okay. This is straightforward. This is one step that should have taken you no more than 10 seconds. Once you saw this, you should know, well, okay, this is a derivative of Q, then Q is going to be the antiderivative. Now, I haven't talked about the integration constant, okay? And I'm just going to wave my hands over that because we don't have a lot of time right now, okay? You can figure out why. Okay, got it? Okay, well, that's pretty good. Now, what do we have? Well, we got our Q function, right? So now, we have the voltage function for our capacitor, which is just Q over C, and we've got Q, right? And we have, this is not the capacitor, this is a resistor. Okay, we have the capacitor here. And we got the voltage function of the capacitor, but that's the capacitor, right? What's the voltage function of the resistor? So what's the total voltage function? V sub S is the voltage of the source. You can draw that right, but you got the idea. Okay?